So we want to find the greatest common factor. The way I explained last time is to start with the numbers, and we want to write the bigger number in terms of the smaller numbers that you see, if possible. So I see a 5, I see a 10. I certainly cannot write 15 in terms of 10 as a proper factor, but I can write it in terms of 5. So 5 times 3. 10, 5 times 2, and 5 times 1. Yes. So I can combine those. So for the numbers, the common factor is 5. Next, I have the a terms. I want to write a cubed in terms of the lower factors. I only have one of them. So a cubed, I can write it as a squared times a. And a, I can write it as 1 times a. So for the variable a, the common factor would end up being a. Good. And lastly, for b, we have b squared. I can write it as b times b. And there is b by itself, so b times 1. So the common factor there would simply be b. If I combine them together, the greatest common factor is 5 times a times b. Good. Now, going to pull 5ab out of each term. I go between brackets and parentheses, but if you want to keep it as parentheses, perfectly fine. So you are pulling out a 5. You don't have to think again. You did all the work already. So if you take 5 out of 15, you leave behind 3. If you took a out of, well, if you take a out, you would leave 1 behind. So 3 times 1 is just 1. If you took b out of b squared, you have b left. All of 5ab is taken out from the second term, so that's just 1. Minus, if you take 5 out of 10, you leave behind 2. If you take a out of a cubed, you would leave behind a squared. If you take b out, just have 1, so you'd have minus 2a squared. So the factored version is 5ab multiplied by 3b plus 1 minus 2a squared. Good. So I'm going to do this process one more time, and I strongly recommend that you do it too until you get good practice. But once you have enough practice, you don't even have to write them out separately. It should come to you naturally, and it does with practice. So first, I'm going to start with the numbers. There is a 12, 24, 36. I'm going to start with 36, write it in terms of 12. So 12 times 2, bad, 3. 24, 12 times 2. And there is a 12, so 12 is simply 12 times 1. What do we have in common? We have a 12 in common, so 12 for us. Next, for the a terms, the highest is a raised 4. I see a squared, I see a cubed, so I can write a raised 4 as a squared times a squared. That would be in terms of a squared. in terms of a cubed, it will be a cubed times a. I want to write a cubed in terms of the lowest powers. There is only one, which is a squared. So a squared times a. And lastly, we have a squared. So we will have a squared times 1. So even though we have a cubed here, a cubed there, there is no a cubed here. So that's not the common factor. So the greatest common factor would be a squared. Good. And the last case would be b raised 4. I'm going to write b raised 4 in terms of the lower powers. So b cubed times b. I see a b squared, so I can write it as b squared times b squared. I see b cubed. I can write b cubed as b squared times b. And lastly, I have b squared. I can write b squared as b squared times 1. So what is the common factor? The common factor is b squared. If you put them all together, you will get the greatest common factor to be 12 times a squared times b squared. We're taking the 12 out, we're taking the b squared out, we took an a squared out, which will leave us with a squared. 12, if you take it out of 24, you would have 2 left. I'm taking an a squared out, so that would just be 1. And if I take b squared out of b cubed, I would simply have b. Good. Next term, if I take 12 out of 36, I will have 3. A squared out of a cubed, leave me with just a. B squared, you can take it out, it's just 1. And the last term, 12, comes out. So you have 1. A squared, you took it out, so 1 again. B raised 4. If I take b squared out, I'm left with b squared. Good. So they've made it easy for us. Now you have something like this, you have to look at it and say, well, is there a common factor between the terms that you see? N plus 2n is in this term, and minus you have another n plus 2n. Yes? So n plus 2n is common to that term and that term. So if you pull n plus 2n out, if you like parentheses, you can stick with parentheses. I like to switch between the two, parentheses and brackets. If I pull n plus 2n out of that term, I will have 5n. If I pull n plus 2n out of the second term, I would have 4 with a minus in the middle. Good. So the factored version is n plus 2n times 5m minus 4. Good. So what is the common factor? I see 2a plus 1 here, 2a plus 1 there. Yes, I can pull 2a plus 1 out. If I take 2a plus 1 out of the first term, I would have 7a squared. 2a plus 1 out of the second term, I will have minus 9. So the factored version is 2a plus 1 times 7a squared minus 9. So if we want to group terms, we've got to make sure that we have some sort of a common factor prior to grouping. So what I mean to say is they put things in order, and if you put things in order, that's the best way to have a polynomial expression so that you can group terms easily. So if you switch things around, you're going to mess it up. What do I mean by that? So you can put this as a side note. If you switch the order, just for fun, and if you did that, sure, you get a common term here, which is x, but you have no common term there, right? But if you look at it the way it is provided, if I pull out x squared here, perhaps I might get a common term here. I don't know yet, I might. Good. So I look at x cubed, I look at x squared. What is the common factor between those two terms? What? X squared. If I take x squared out of x cubed, what will I have there? X plus. I took x squared out of 5x squared, so I will have 5 plus. I have a 3x, I have a 15. If I pull 3 out, and you can see the moment I pull something out, I naturally put parentheses. Always put parentheses or brackets. They are helpful. So if you take that 3 out, you have x. 3 out of 15, you will have 5. Good. Do we see something in common between this term, the group term, and that term? X plus 5. And if I pull x plus 5 out, I'll have x squared in the first term, 3 in the second. So the factored version is simply x plus 5 times x squared plus 3. Good. Especially when you deal with negative signs, you've got to be careful. So look at the first two terms. I see a 2 in common. I see m in common. So 2m. If I take 2m out of 2m squared, I will have m. I take 2m out of negative 8mn, I will have minus 4n. Good. Now, want to take a term out from these two terms. So should you simply take out 5? So if you simply took 5 out, I will have m, yes, and well, I actually took negative 5, so negative m and plus 4n, correct? 5 out of the first term, negative m, 5 out of the second term, 4n, yes? But then you realize, oh, this term and that term could have been the same had you not pulled out 5, rather you pulled out negative 5. Yes? So if I pulled a negative 1 out, negative 1, if you pull that out, you'd have m. From a positive, you take a negative out, you will have minus 4n. Good. Now you can see a term that is in common between the two grouped terms, m minus 4n, m minus 4n. If you pull m minus 4n out, you have 2m in the first term. 5 times negative 1, I have negative 1. Good. So that is factor 4. Good. You can always verify your answer by distributing, and you should get that back. Say, if by some chance you forget to take negative 5 out, and you simply took positive 5 out, you'd end up with this factor. But then you look at the factor and you realize, well, this term and that term, they differ only by a negative sign. So you should have pulled out a negative 5 and not a positive 5. So you can change your mind at a later point in time. So with practice, you will know exactly as to which factor to take out. But if you make a mistake, the goal is to come up with a common factor. So how do I get the common factor of m minus 4n from this term if I pull a negative 1 out? So this extra step, I wrote it because some of you might do the very first step and get stuck. Good? See the difference? So it's not necessary. I could have pulled a negative 5 out from the beginning. So 2 at a time. So what do we see in common between the first 2 terms? C squared. If I take c squared out of the first term, I'd have c a times b. C squared out of the second term, I'll simply have 3 plus. You just have AB plus 3 left, correct? And you may say, well, the answer is c squared times AB plus 3. That's not true. So if you don't see something, there is always a 1 as a factor. Good? So if you don't see something in addition, you can always throw in a 0, correct? If you don't see something in multiplication, there is always a 1. 1 is a factor of every expression. So 1 times AB plus 3. Now, AB plus 3 is common to both terms. I can pull that out. If I take AB plus 3 out, I would have c squared plus 1. Good.